Imagine a world where yesterday, today, and tomorrow all exist at once. A world where you could have tea with Shakespeare in the morning, lunch with Einstein in the afternoon, and dinner with your future self in the evening. This world, my friends, is the world of time travel. It's a concept that has sparked the imaginations of storytellers and scientists alike. From H.G. Wells to Stephen Hawking, it's a realm that resides somewhere between the pages of science fiction and the equations of theoretical physics. It's the dream of stepping into a machine, a portal, a vortex, and emerging in a time that is not our own. A dream of unraveling the mysteries of the past and unlocking the secrets of the future. It's a fascination, an obsession, a yearning that transcends the boundaries of possibility. But how could such a fantastical scenario become reality? What does science have to say about it? You might be surprised to learn that time travel isn't just the stuff of science fiction. In fact, it's a concept deeply rooted in modern physics. Let's start with a simple yet profound idea proposed by Albert Einstein. Time is not a constant, but rather a fourth dimension. Imagine this. We live in a three-dimensional world, right? Up, down, left, right, forward, and back. Now envision adding another dimension, one that's not spatial but temporal, time. It's as if we're all constantly moving forward in this fourth dimension, one tick-tock at a time. Now, what if you could move through this fourth dimension not just forward, but backwards as well? Or faster or slower? That's where things get interesting. Picture yourself on a train. The train represents time, steadily chugging along. If the train speeds up, time, relative to someone standing still, appears to slow down. This is what we call time dilation. It's not just a cool concept, but something that's been tested and confirmed with atomic clocks on fast-moving airplanes. Now, let's move to another fascinating concept: wormholes. Imagine you have a piece of paper representing the fabric of space-time. Normally, to get from one side to the other, you'd have to traverse the entire length of the paper. But what if you could fold the paper, bringing two distant points closer together? That's the essence of a wormhole. A kind of shortcut through the fabric of space-time. But here's the catch. While wormholes are theoretically possible, we've yet to discover one. And even if we did, they'd be incredibly unstable, requiring some form of exotic matter with negative energy to keep them open. So where does all this leave us? Well, according to the laws of physics as we understand them, time travel could be possible. It's a mind-boggling concept, isn't it? But don't pack your bags for a trip to the Jurassic period or the distant future just yet. So, in theory, time travel is possible. But how about in practice? Can we actually build a time machine? The idea of hopping into a time machine and zipping off to another era is certainly exhilarating, but it also brings up some brain-bending paradoxes. Imagine this. You've got your hands on a time machine. You decide to take it for a spin, back to when your grandfather was a young man. But in a twist of fate, you accidentally prevent your grandparents from meeting. This might seem like a harmless prank, but think about it. If your grandparents never met, they never had your parent, which means you were never born. But if you were never born, how could you have traveled back in time to stop them from meeting? This is what we call the grandfather paradox, a classic example of the mind-boggling implications of time travel. But that's not the only paradox time travel presents. Let's explore another one. The bootstrap paradox. Picture this. You're a brilliant scientist with a time machine. You travel to the future and there you find a groundbreaking scientific theory. You're so impressed that you take it back to your own time and publish it, becoming famous. But here's the catch. Who originally came up with the theory? You took it from the future, but in the future, they learned it from your publication. This paradox raises questions about the origin of things when time becomes a loop. These paradoxes underscore the complexity of time travel. They illustrate how our actions in the past could ripple through time, altering the present and the future in ways we can't even begin to fathom. And they highlight the potential dangers of meddling with the timeline. But despite these paradoxes, the allure of time travel remains. The ability to witness history firsthand or to see what the future holds is a tantalizing prospect. Imagine, for instance, being able to witness the signing of the Declaration of Independence, or to see if we ever establish colonies on Mars. Time travel, it seems, is a concept fraught with questions and paradoxes. It's a concept that challenges our understanding of the universe and our place in it. But perhaps the most intriguing question of all